Gold melts at 1064 degrees Celsius. Yeah, that's hot. But what if I told you that's just the beginning? Most people think that's where the story ends, but in reality, it's just the first chapter in gold's wild transformation. Let's crank up the heat and see what really happens when gold goes wild. We're not just talking about a little extra warmth, we're talking about pushing gold to its absolute limits, way beyond what you'd ever see in a jewelry store. Trust me, you've never seen your jewelry like this before. Imagine your favorite gold ring or necklace, but instead of sparkling on your finger, it's about to be transformed into something almost unrecognizable. Gold isn't just a symbol of wealth or a material for bling, it's got some seriously weird science hidden beneath all that glitter. Underneath its shiny surface, gold is a playground for physics, chemistry, and even a bit of cosmic mystery. Today I'm going to show you what happens when gold isn't just melted but pushed past its limits. We're going to take it to temperatures where most metals would simply give up and vaporize. Not just liquid but superheated. And I promise things get strange fast. Gold starts to behave in ways you'd never expect from a metal that's usually so calm and collected. So here's the deal. At its melting point, gold goes from a solid block to a pool of liquid sunshine. It's mesmerizing to watch, almost hypnotic, as the rigid metal softens and flows like honey. But if I keep heating it, way beyond melting, it's not just a hotter puddle. The energy we're pumping in starts to change the very nature of the gold itself. The atoms start moving like they've had way too much coffee. They're vibrating, bouncing, and colliding at insane speeds, turning the gold into a chaotic dance of energy. First you might see it bubble, then vaporize, or even turn into plasma, which is kind of like a mini lightning storm inside the crucible. Plasma is the fourth state of matter, and it's not something you see every day, especially not with gold. And if you keep going, that gold can literally boil off into a gas at 2,856 degrees Celsius. That's hotter than lava. Imagine gold, the ultimate symbol of stability, just vanishing into thin air. Now let's see it in action. This isn't just theory. We're about to witness gold's wild side right here in the lab. Here in the lab, when I superheat gold, check out this footage. It doesn't just sit there politely. The surface comes alive, reacting to the intense energy we're throwing at it. It goes wild, bubbling and spitting out tiny droplets, almost like golden fireworks. Each droplet is a tiny explosion of energy, a miniature display of gold's unpredictable side. Those droplets? That's gold being tossed around by insane energy, behaving more like a tiny sun than a boring old metal bar. It's a reminder that even the most precious metals can have a wild side when pushed to extremes. But here's where things get truly unexpected. When you push gold this far, you unlock behaviors and properties that are almost never seen in everyday life. If you cool down superheated gold really fast, it can actually form bizarre tiny crystals that you'd never see in regular jewelry. These crystals can have unique shapes and structures, sometimes even forming patterns that look like they belong in a sci-fi movie. And under extreme conditions, gold vaporizes so quickly it forms a shimmering golden mist. It's like watching a cloud of pure gold drift through the air, something you'd expect from a fantasy novel, not a real-life experiment. It's like seeing alchemy in reverse. Instead of turning lead into gold, we're watching gold transform into something almost magical, right before our eyes. So why does this matter? Why go to all this trouble to push gold to its limits? Well, it turns out, these extreme behaviors have real-world applications. Well, understanding what gold does at wild temperatures isn't just for show. It's crucial in electronics, where gold wiring has to survive heat, and where even a tiny change in its properties can make or break a device. In aerospace, gold is used in places where parts face intense temperatures, like in satellites and spacecraft. Knowing how gold behaves under these conditions can mean the difference between mission success and failure, and even in figuring out how gold formed in exploding stars. The gold in your ring might have started its journey in a supernova, forged in temperatures and pressures we can barely imagine. This isn't just money you can hold, it's a glimpse into the wild physics of the universe. Every piece of gold is a tiny piece of cosmic history, shaped by forces both earthly and astronomical. So next time you see gold, remember, it's got a lot more going on than just being shiny. It's a metal with a story, a past, and a future that's as wild as any science fiction tale. Heat it up past its limits and you're in for a surprise. Gold isn't just precious, it's powerful, unpredictable, and full of secrets waiting to be unlocked. If you learned something new today, smash that like button and subscribe for more wild science experiments that'll melt your mind. See you next time.